Hello everyone, today we are going to talk about real zeros of polynomials. We are going to start with rational zeros. Second. And like that, it's the squares are too big. So we're going to start with rational zeros. Sorry. What are rational zeros? Rational zeros can be represented as a fraction, right? Like P over Q. P and Q are integers. So square root of 2 is not a rational number, but 2 over 3 or 5 over 7 or minus 5 over 7 are rational numbers. So let's consider a simple polynomial for which we obviously know the roots or zeros. Something like x minus 2 and x minus 3. Somebody factored this polynomial for us already. What are zeros? Well, we know that zeros are what is turning this parenthesis into zeros. So the first one is going to be 2, and the second one is going to be 3, right? So zeros are 2 and 3. If we open this parenthesis, we are going to have what? X squared, x by x, minus 2x minus 3x, and I'm going to write it down plus minus 2 by minus 3. These are products of the free terms in each of these factors. And as a result, we have x squared minus 5x, like minus 2 minus 3. And I'm going to have plus minus 2 multiplied by minus 3. What I'm trying to say, guys, I'm not trying to say that minus 2 multiplied by minus 3 is not equal to 6. I'm trying to say that what we have over here is going to be a product of our zeros. Just our zeros are 2 and 3, right? And we do have minus in front of them, but normally we understand that like the number is supposed to be positive. So you are going to have over here 6, which is going to make a product of our zeros. So the inverse is also true, that for the free term, it's made out of like product of zeros, means that zeros of polynomial, in our case like quadratic, are going to be factors. So I'm going to say that 2 and 3 are factors of 6. Well, for quadratic polynomial, it's kind of obvious, or like, very easy to understand, like how to find zeros, right? But if you have something more complicated, like a cubic polynomial, 5th degree polynomial, there's still going to be a multiplication of all numbers without x eventually, and that's going to make up a free term, right? And that means that zeros are going to be what? Factors of this free term. The only one little obstacle here is that it's not always that x squared has coefficient 1. Here, the coefficient of x squared equals to 1, right? But sometimes x squared is going to have a coefficient. Let's consider this case. Imagine that we have 2x minus 1 and x minus 3. What are actually zeros here? Well, I'm going to take 2 outside of parentheses in the first one and write down x minus 1 over 2. It's kind of, I divided 2x by 2 and 1 over 2. X minus 3. Now, if I again multiply everything and keep 2 outside, I'm going to have x squared minus 1 over 2x minus 3x, and the final thing is going to be 1 over 2 multiplied by 3. These two minuses are going to give me plus. So it's 1 over 2 multiplied by 3. Again, 1 over 2 is 0, and 3 is 0 of the polynomials, right? x1 and x2. And here we have a product of them. But if you write it down as one number at 3/2, you won't really know like what was multiplied. Was it like 1/2 multiplied by 3, or it was 3/2 multiplied by 1? So normally, if the coefficient of x is not equal to 1, you don't really, like, if we divide by it to get like what was multiplied, we don't really know what actually zeros were. Was it like 3/2 multiplied by 1 to give you a product, or it was actually what it was, 3 multiplied by 1/2? Or so what we are going to do, guys, when we find our possible zeros, we are going to look at our fraction 3/2, and we are going to pick up all possible factors of 3. So we're going to write down plus minus 3 and plus minus 1, only two factors, right? And also all possible factors of 2, plus minus 2 and plus minus 1. And then we are going to make possible variations of the root by combining all these numbers together. For example, 3/2 is going to give us plus minus 3/2, right? 1/2 is going to give us plus minus 1/2. And then if we divide by 1, we are going to have plus minus 3 and plus minus 1. Well, again, we already know what are zeros of this polynomial. We know that they are 1/2 and 3. But as a method of finding zeros without actually solving equation, just guessing using this free term, we'll need kind of something to check. What we have over here to check? Well, our 0, 1/2 is going to be this one, right? Our 0, 3 is going to be this one. And all the rest of them are going to be just like possible zeros, but not actual. Well, we're kind of going to accept it and just say that, well, there are 1, 2, 3, 4, 5, 6, 7, 8 numbers to check. It's not difficult to check by just plugging into the polynomial, because, you know, if it's a 0, polynomial turns into 0. And that's going to be like a little bit easier than trying to solve the quadratic equation or cubic. Well, for quadratic, not really, but if you have an equation of like higher degree, it's going to be a little bit easier to just plug in the numbers into polynomial instead of really solving polynomial. Because for lots of polynomials, we don't have a formula like for quadratic polynomial. This method works for higher degrees too. So now I'm going to consider example of a cubic equation and show you how we solve this cubic equation or find actually zeros. X cubed minus 3x squared plus 2. So what are possible zeros? Here the coefficient of x equals to 1, so we are not dividing 2 by nothing. So usually it's like 2/1, right? But because it's 1, we are going to assume that that's plus minus 2, here plus minus 1, which is going to give us only like 2 combinations, plus minus 2, sorry, plus minus 1 here, also dividing 2, right? Plus minus 1. Okay. So these are possible zeros. Possible. They're factors of 2, right? Are they actual zeros? Now we are going to check it. Well, how are we going to check it? We're just going to plug it in, right? You know, if it's a 0 of polynomial, it turns it into 0. So I'm going to just take polynomial at 1. Plug 1 here, 1 here. And I see that 1 minus 3 plus 2 is 0. Yeah. So actually x equals 1 is 0. Now, we need to use it somehow, because if you want to find other zeros, we can actually factor this x equals 1 out of our polynomial. I'm going to use synthetic division to do this factoring. So I'm going to copy the coefficients of my polynomial, like 1, 0, minus 3, and 2. Remember, why do we write down 0 instead of x squared? Because there is no x squared. And I'm going to copy 1, which is 0. And start doing this synthetic division. Copy this one down. Copy this one down, right? Now multiply this one by this one, get me 1, add them up with 0, and get one more 1 here. Now 1 by 1 is going to give me what? Again, 1. Minus 3 plus 1 is minus 2. 1 by minus 2 is minus 2, and that's 0. We know that remainder is going to be 0, just because, remember, remainder theorem. If something is 0 of the polynomial, then remainder equals to 0. What is over here? What is quotient? Remember, quotient kind of goes from t term and that the first power, and this is the second power. So actually we have x squared plus x minus 2. So we actually factored a little bit this polynomial. That's a quotient, x squared plus x minus 2, multiplied by x minus 1, which was 0, which we kind of found, right? Well, that's one way to kind of first figure out whether it's 0 or not, and then kind of make the degree of polynomial lower. Can I solve this one? Yeah, I can solve this as quadratic polynomial. I can solve it using the formula. I don't need to use this zeros theorem, and that's going to be a very wise way to do instead of like checking the numbers, right? But, well, again, you can still check these possible zeros. Maybe one of them is going to work again. Let me kind of find the solution over here. So what I have, plus minus square root of 1 plus 2 multiplied by 4, supposed to be minus, but there is one more minus here. And then x squared minus 1 divided over 2, right? This 1 produces 1 over here, and 1 in front of x produces minus 1 here. So what I have, plus minus, and this is 1 plus 8, which is going to give me what? 9, right? Square root of 9 is 3 minus 1 over 2, and that's going to give me 3 minus 1 is going to give me what? 2 over 2 is 1. And minus 3 minus 1 is going to give me negative 4 over 2 is negative 2. So actually what I have, besides this 0, I have one more time the same 0 and one more time the negative 1, negative 2. What does it mean? Actually, if I check this one back into equation, it would work again. And we kind of see that if you plug in 1 here, 1 plus 1 minus 2, yeah, it's 0. And this 1 minus 2, if you plug it into equation, it's also going to turn it into 0. Well, I'm going to write down polynomial p of x in factored form, p of x. So I'm going to start with x minus 1 for this 0, and then x minus plus 2 for this 0, it had minus already, and x minus 1 for this 0. Cubic polynomial can be represented as a product of 3 linear factors with x in it. Okay. Well, what should we do next? Well, let's consider something a little bit more complicated. Next example, p of x equals 2x cubed plus x squared minus 13x plus 6. So what I'm going to do, guys, well, I'm supposed to divide by 2 actually all polynomial, because normally if I calculate zeros are x minus actually number. Well, I'm going to do it like mentally, so I'm just going to write down that it's 6, and the denominator is going to be 2, so I'm kind of dividing by this 2. Well, what are possible factors of 6? Plus minus 3, plus minus 2. Sorry, I'm going to write it down actually below a little bit because my line is not. 6 over 2. Possible factors of 6, plus minus 3, plus minus 2, plus minus 1, and plus minus 6, right? Denominator, possible factors of 2 are plus minus 2 and plus minus 1. Now we are going to have lots of combinations of these factors. Well, I'm going to start with plus minus 3 over 2, and then plus minus 1, 2 over 2, and plus minus 1 over 2, it's 2, 1 over 2, right? And plus minus 3, 6 over 2, and then I'm going to divide 3 by plus minus 1, still going to give me 3, so I'm not going to repeat it second time. 2 by plus minus 1 is going to give me 2. And 1 is going to give me 1, but I already have 1, so I don't have to copy it. And 6 is going to give me just plus minus 6. Well, we have lots of different factors. So do we have to check all? No, guys, check the most suspicious. My suggestion, start with integers. Try to check both plus and minus, and then try to see if they are giving you 0 when you plug them in. For example, for 1, it's very easy to check. You plug in 1 into your polynomial and see, is it going to give you 0 or no? Well, I'm going to plug in 1 because 1 is one of my factors. So it's 2 plus 1 minus 13 plus 6. Well, obviously it's not equal to 0. Now I'm going to plug in 2. Again, start with easy numbers. So it's 2 cubed plus 2 squared minus 13 by 2 plus 6. 2 cubed is 8, by 2 is 16, plus 4 minus 26 plus 6. This is 20, plus 6 is 26, and minus 26, yeah, it's 0. So x equals 2 is going to be my 0. What I'm going to do next, guys, I'm going to separate it from the equation because I want to turn cubic equation into quadratic, lower the degree. So I'm going to copy the coefficients, 2, 1, minus 13, and 6, and write down over here 2, and do this synthetic division. So this 2 goes down, 2 by 2 is 4, 1 plus 4 is 5, 2 by 4 by 5 is 10, 13 plus 10 is minus 3, and minus 3 by 2 is 6, minus 6, so it's supposed to give me 0. Well, it's supposed to be actually equal to 0, that's remainder, right? And this one is going to turn into equation 2x squared plus 5x minus 3. Now, what we can do, guys, if you wish, you can continue checking the numbers, but easiest way is to just use the formula actually, because, well, checking the numbers can kind of, there are so many numbers left. It's like 1, 2, 3, 4, 5, 6 multiplied by 12 numbers. We just checked 2 of them, right? So we have 10 more to check, and they can be repeated. For example, we know that 1 is not a root, so we already checked it forever. But 2, because it's a root, it can be kind of one more, can be a root one more time. So I'm not going to solve it using this check one more time. When you get quadratic equation, use the formula to solve it. That's what I'm going to do. X12 equals plus minus a square root 5 squared is 25 plus, because there is a minus 2 by 3 by 4, 4ac, and then minus 5 and divided by 4, right? Because it's 2 by 2. So what I have, maybe it's not going to give me very nice solution, but let's check. 25, and this is 2 by 3, 2 by 3 is 6, and by 4 is 24, and 25 plus 24, oh, that's 49. So I have a square root of 49 minus 5 over 4. Square root of 49 is 7 minus 5 over 4, and 7 minus 5 is going to give me 2 over 4, which is going to give me 1 over 2. And minus 7 minus 5 is going to give me what? 12 over 4, which is minus 3. Well, I'm almost done. So I'm going to actually write down this equation in the form of x minus 1 over 2 and x plus 3. So I did factoring, right? The only one little thing that actually x here had 2. So what I'm going to do, guys, I'm going to multiply by this 2 outside to kind of make sure that my equation is matching this one. So it's going to give me 2x minus 1 plus 3. And the factor which I found already was x minus 2. So I factored my polynomial. Normally, you won't need to factor the polynomial. If I'm asking you to find the roots, it's going to be enough for me to write down this zeros. X1 equals 2, x2 equals 1 over 2, and x3 equals negative 3. Okay, so that's how we solve the factor the polynomial. Well, now guys, I'm going to solve one more problem just to make sure that you go through the details well. And that's going to be a long problem because it's going to be like a 5th degree polynomial. But because I know the answers, I'm going to check only correct solutions. But generally, we have to check all of them more like randomly. So one more example. Polynomial is going to be 2x to the power of 5 plus 5 to the power of 4 minus 8x cubed minus 14x squared plus 6x and plus 9. Wow, that's a long polynomial, right? Degree is 5 and all terms are here. So let's first figure out like which roots are we going to have. We have this number and we have this number. Let me kind of circle them. So it's going to give us 9 over 2. So here plus minus 9 plus minus 3 plus minus 1 in denominator plus minus 2 and plus minus 1. Now what roots can we form in them? Plus minus 9 over 2 plus minus 3 over 2 plus minus 1 over 2. Plus minus 9 if we divide by 1, right? Plus minus 3 and plus minus 1. Wow, so many roots again. Well, we are not going to check all of them. So I'm going to just start with something simple. I'm going to check x equals 1. Yeah, guys, I'm going to check x equals 1 by just substitution. And if it works, I'm going to do synthetic division. If it doesn't work, I'm going to just drop it. So I'm going to check x equals 1. So p of 1 equals 2 plus 5 minus 8 minus 14 plus 6 plus 9. Let me check it. 2 plus 5 is 7. Minus 8 is minus 1. Minus 14 is minus 15. And 6 plus 9 is plus 15. Yeah, I was right. This is 0. What I'm going to do next, I don't want to randomly check the roots into this big fifth degree polynomial. I'm going to actually separate this root from the polynomial to factor it. To do this, I'll need to do synthetic division. Guys, you actually can do synthetic division when instead of substitution, because synthetic division, if it gives you 0 as a remainder, that's going to be same 0 as over here. But again, that's up to you how you like solve it, how much time you have. I'll try not to give you high degree polynomials, but still you will need to know how the method is working. So we have 1 over here. And I'm going to start, I copy this 2 down, and then 2 by 1 is 2, 7, 1 by 7, 7 minus 1, that's going to be minus 15. Minus 15 is going to give me minus 9, and minus 9 is going to give me 0. So that's a remainder. The polynomial I have is over here. That's actually fourth degree polynomial. I'm going to write it down. 2x to the power of 4 plus 7x cubed minus x squared minus 15x minus 9. Well, I'm going to check other roots. I don't want to waste your time on checking the roots which are not going to work. So I'll try to check the roots which are going to work, okay? So the next root I'm going to check is going to be -1. Let's see if it's going to work. And again, usually guys, start with easy roots because they're just easier to check. What I'm going to do, guys, I'm going to just perform synthetic division on this polynomial of fourth degree because I factored already that one. So x minus 1, that's my total polynomial. That's one which I kind of fourth degree, and this the factored one. Well, it's very easy to copy the numbers. You're just copy numbers from over here. 2, 7, minus 1, minus 15, minus 9. And if you check -1, you write down -1 here. And you are going to have 2, minus 2, which is 5, minus 5, which is minus 6, 6 over here, and minus 9, and 9 over here, and 0 again. So remainder is 0, means that that's a root, and my polynomial is even shorter. Now it's 2x cubed plus 5x squared minus 6x minus 9. And multiplied by x minus 1 by x plus 1. X plus 1 comes from this -1. So it's actually x minus -1 plus 1. Okay. So what other roots I'm going to check? I'm going to check -1 again. Well, why not? Can be also the root. I know that 1 is not going to be the root, just you can just literally substitute 1 here, like 2 plus 5 is 7, minus 6 and minus 9 is not going to give you 0. But how about -1 again? -1. So now you just copy these numbers. 2, 5, minus 6, minus 9. And then you move this 2 down, -1 by 2, -2. So it's 3 here, -3, -9, and 9 again, 0. Yeah, that's a root. Remainder is equal to 0. And this is quadratic polynomial 2x squared plus 3x minus 9. Wow. So guys, we already factored our polynomial of fifth degree to quadratic one, 2x squared plus 3x minus 9. And we have x minus 1 from this one, x plus 1 from this one, and one more x plus 1 because that was the second root. Good. Should we factor further? No, guys, we are going to just solve it. Okay, so that's what I'm going to do. Actually, you can continue checking this list of the roots. Actually, why don't we check something from the list? Normally, guys, when we have quadratic equations, solve it using the formula. But I want to show you some, like one more check. Let's check -3. Well, again, I do know the answers. That's why I'm checking that code, but x equals -3. Okay, I'm going to copy 2, 3, -9, and -3 here, and let's check. So 2 goes down, 2 by -3 is -6, right? -3, here 9 and 0, yeah, remainder is 0, so that's a root 2. Which means that my polynomial is now 2x minus 3, this one, right? And remember, this is a free term, that's the first power, and whatever happens in left direction are going to be increasing powers. X plus 3 instead of x minus 3, because it's like x minus -3 is x plus 3, right? Next, x minus 1 and x plus 1 squared. I'm just copying what I have on the top over here, these two factors. That's it. I factored it. Okay, very good. Now, guys, I want to give you a problem to solve on your own and see if you can do it on your own. Again, I promise to not give you anything of fifth degree, just because it's kind of very, very long. But we can try something of that cubic. For second degree, you can use the formula, but for cubic equation, there is a formula, but you don't know it. So I'm going to give you one self problem. So problem, polynomial p of x equals 3x cubed minus 5x squared minus 8x minus 2. And I'm asking you factor it. And find zeros. Again, you can do it. You can stop the video and do it. And I'm going to count to 5 and provide you with solutions. So 1, 2, 3, 4, 5. Solution. Well, what I have 2 here and I have 3 here. So it's like 2 over 3. Plus minus 2, plus minus 1, factors of 2. Plus minus 3, plus minus 1, factors of 3. So possible roots are plus minus 2 over 3, plus minus 1 over 3, plus minus 2, and plus minus 1. So I'm dividing every numerator by 3 first, and then by 1. Okay, not too many, just 4 roots, right? The only bad thing here is that well, it doesn't look like 1 is gonna work, right? Let's just try to check 1. 3 minus 5 is minus 2, minus 8, and minus 2. Well, it's not going to give us 0. So I'm not gonna even check 1. And I don't think that -1 is going to work out. So just quickly, minus 3 minus 5 is minus 8 plus 8. is going to give me 0, but -2 again, not working. So I'm going to circle this. These two roots are not working. So I'm going to check only this. Why I'm checking one? Ones are easy to check. They are just like, you either like just count the coefficients or, well, watch which coefficient is going to change the sign and put minus in front and try to count. It's easy. You don't need to raise anything to powers because 1 to any power is just 1 or either 1 or -1. So now I'm going to check whatever is remaining. Just 6 numbers, right? Guys, I wanna try number 2. Okay, so let's check x equals 2. I'm going to just do the synthetic division for 2. So it's 3 minus 5 minus 8 minus 2 and 2 over here. Doesn't look like it's going to work, but let's check it. 3 here, 6, 2 by 3, right? So that's 1, that's 2, minus 6, minus 12, and that's going to give me what? Minus 14. Obviously not equal to 0. That's my remainder, so it's not a root, not 0. Well, now guys, I'm going to check something weird, like, because I have like this 2, 1 over 3 and 2 over 3. I'm going to check one of each. So I'm going to start with negative 1 over 3. I'm going to check positive 1 over 3. Let's check positive 1 over 3 first. So 3 minus 5 minus 8 minus 2 and 1 over 3. So I'm going to copy 3 here. Well, 1 over 3 by 3 is going to give me 1. Here is going to give me minus 4 and minus 4 by 3, negative 4 over 3. And I obviously see that it's not going to combine into 0. Well, guys, what I'm going to do, I see that if it was not minus 4, but minus 6, it would give me like minus 2 and I multiply by 1 over 3. So what I'm going to do, I'm going to put minus here and redo my division. I don't want to copy everything. I'm just going to put extra minus here. So if I put 3 is still here, right? But if I multiply it by negative 1 over 3, I'm going to get minus 1 here. How minus 1 is better? Watch. Minus 5 and minus 1 is minus 6. Minus 6 by minus 1 over 3. Minus disappears, right? And 6 over 3 is 2. It's going to give me something nice over here like 2. Well, 2 is not super nice, but if you add it to negative 8, you're going to get negative 6. And if you multiply it again by 1 over 3, you are going to get positive 2, right? Because it's like minus and minus cancels, and 6 over 3 is 2, which is going to give you 0. So that means that this is a root 0. Perfect. Should I continue doing this division? Now, guys, I'm going to write down my polynomial. Quotient 3x squared minus 6x minus 6. And here x plus 1 over 3. Quadratic one, I just can solve it. Why it's going to be good to solve quadratic one? Because actually, not all roots of polynomials are always rational numbers. Sometimes you can get square root of 2 and square root of 7 or whatever. And the method which we use cannot figure out these roots. If there are roots like this, our method is not going to find them. So, for example, if you took all these like numbers, there are 8 numbers, right? You check them all, and none of them is a root. It does not mean that there are no roots of the polynomial or no zeros of the polynomial. It means that they are not rational numbers. They can be like square root of 2 or square root of 7. What I'm going to do, guys, I'm just going to solve this one. I'm going to just solve this. 3x squared minus 6x minus 6 equals to 0. So x1, 2 equals plus minus square root of 36, right? This cube is squared minus and minus plus 4, 3, 6, and plus 6, and divided by 2 multiplied by 3. So what I have, plus minus 36, and this is what? A 3 by 4, 12 by 6, 12 by 6 is going to give me 60, 72. 72, so I'm getting like plus minus square root of 108, I think. plus 6 divided over 6. Well, I'm going to do the division. The good idea was to cancel actually 3, divide the whole equation by 3, because I have a calculator to extract the root of 108. Obviously, it's not a perfect square, but maybe I can divide it, for example, by something like, I don't know, maybe 6. Well, let me see, 108. If I divide it by 6, what I'm going to get? A 4. 1, sorry. 1. If I divide it by 6, 48, 18, and 6 by 6 by 3. Yeah, I'm trying to factor 108. Okay. What I see is that 108 is 6 by 6 by 3. 6 over 6. Well, I can extract this 6 out of the plus minus 6 square roots of 3 plus 6 over 6. Now I'm going to cancel 6 in numerator. Plus minus square root of 3 plus 1. That's going to be my final root. You see that this root is not rational. What does it mean? It means that after this root, you won't be able to find any good roots which are producing 0 remainder for this, or zeros. So this, all of this, except like minus 1 over 3, except this one, are not going to be zeros. So if you continue this process of checking, you would find nothing. But quadratic equation give us solution. So I'm going to write down the like factored form first, and then zeros separately. P of x. Well, guys, what I'm going to do, I'm going to write down x minus the first root, 1 plus square root of 3, x minus the second root, 1 minus square root of 3, and x plus 1 over 3. And because my x had a 3 in front, I'm going to kind of have a 3, because I want to get like 3. It's not going to look very nice. Simplifying it. I multiply this 3 by this parenthesis. I'm going to get 3x plus 1. So, zeros. Zeros. X1 equals negative 1 over 3. X2 equals 1 plus square root of 3. Well, I switch order here. You can always write it on 1 plus minus square root of 3. And x3, 1 minus square root of 3. Okay, very good. So we kind of solved this problem too. Guys, I'll not ask you to solve anything higher than third degree equation. So normally what I expect from you on the quiz, I expect from you to write down possible zeros and try to guess which ones are going to work. And you're supposed to just guess about 1, 0. After you guess about that 1, 0, you divide your polynomial by x minus that 0. Get quadratic polynomial, solve it by the formula. Okay. Okay, that's all for today. And please do your homework. I know that some people are behind on the homework.